Hi, gentlemen. Today we're working on section 5.3. The lesson is about common factors. And below here are some basics from grade 9 that we should be carrying over to grade 10. So let's take a look at coefficients and variables and degrees of each term. And letter A here, the coefficient is the numerical coefficient, that is 2. The variable is, if you remember from grade 9, is the letter or letters and their exponent. So in this case, the variable is x cubed. The degree is 3 because there's only one term and the highest degree of that term is 3. Negative x is technically a negative 1x, but for proper form we don't write the 1. The coefficient is negative 1. The variable is x. Again, there's an exponent of 1 on that, but for good math form, we don't write the 1. The degree is the first. Okay, moving right along. Simplify when possible. These are like terms, 2x plus 3x. Like terms will have the same variable and its exponent. In this case, we have x and x. We have 2 x's and 3 more x's. Altogether, we have 5 x's. In B, when we're multiplying, we multiply the numerical coefficient first. So we'll multiply 2 times 3, which is 6. And then the x and the x multiply to get us x squared. For C, 2x subtract 3x is negative 1x. But again, we don't write the 1, so it's negative x. Keep in mind it says when possible, correct? So some of these will not be possible. 3x minus 2x is simply x. It's kind of like question C, but reverse order. 3x divided by 2x. 3 divided by 2 is 3 divided by 2, or 1.5. And the x, remember with the quotient rule, there's an imaginary 1 on that x, an imaginary 1 there. And when you're doing division, we learned last year with the quotient rule that we do x to the power of 1 minus 1. And earlier this year in grade 10, we did zero negative exponents, and that would be x to the power of 0, which you know is equal to 1, because anything divided by itself is 1. And so we're just left with 3 over 2. F, when we're multiplying exponents, this is the product rule. X to the power of 5 times x to the power of 3 is x to the power of 5 plus 3. So we add those exponents together and we'll get x to the power of 8. Here we have addition. 2x squared plus 3x squared is 5x squared. Because this is the same, because this is the same as this, we consider those like terms. What we have in a letter H is the power of a power rule. So basically what's in the brackets is being multiplied by itself 3 times. But the shortcut to that is to multiply the 2 times the 3, and we'll have x to the power of 6. But if you did expand it, you'd have x squared times x squared times x squared, and then you would simply add the exponents. I'll show you what I mean. If we had expanded that, it'd be x squared times x squared times x squared, and then that would be the product rule, adding all the exponents, and that would equal x to the power of 6. But this is a shortcut. What I showed you earlier is a shortcut. Moving to letter I, 2x squared plus 3x. This is not the same as that. X squared represents a different number than x, therefore not possible. Doesn't mean no problem like you would do in texting, it means not possible. Okay, 2x squared times 3x. You can multiply these. 2 times 3 is 6. And x squared times the x would get us x cubed. Again, they don't have to be alike to multiply. K is a little bit interesting. We have technically there's an imaginary 1 we don't write there for good form. So I really have negative 1x cubed times negative 1x cubed, because we know it's the exponent 2, so it's times itself. Negative 1x cubed times negative 1. If we multiply the negative 1 times the negative 1, that would get us positive 1. I'll show you that in a different color here below. So again, negative 1x cubed times negative 1x cubed. The negative 1 times a negative 1 gets us a positive 1. And and x cubed times x cubed, we'd have x to the power of 6 because we'd add those. But remember, we've got to delete that 1 because for a good form, we don't write the 1. So it just equals x to the power of 6. And that's what that is going to be right here. Okay? I don't like the way that 6 looks, so I'm going to change that up a little bit. Okay. And 2x, multiply the numerical coefficients first. 2 times negative 3 is negative 6. And x times the x gets you x squared. Okay, so again, just some review from grade 9. Now we're going to look at factoring a binomial. Okay, and that's what we did yesterday. We did the expansion of binomials. We multiplied numbers, binomials, for example, x plus 3 times x plus 5. And factoring will, instead of expanding this to get standard form, we're going to take standard form and get back to what looks like a root form. To factor a GCF of a binomial, and to factor by grouping. So GCF, remember, is the greatest common factor. The greatest common factor of 3x and 4x, I'm looking for what they have in common. And what they have in common is technically a 1x or x. So in this case, x is what they have in common. The greatest common factor of 16x and 24x squared is a little bit different. What is the greatest common factor? Well, in elementary school, you learn to do factor trees. So 1 times 16, 2 times 8, and 4 times 4. For 24, you learned 1 times 24, 2 times 12, 3 times 8, 4 times 6. So if you look at this, what the greatest common factor here would be 4. I apologize. Clearly not 4, it's 8. 8. Okay. So I'm just going to look at that. So the greatest common factor between the numerical coefficients is 8. And with respect to the variable or variables and their exponents, this is x to the power of 1. Here I have x to the power of 2. So what we have most in common is only an x to the power of 1. So I can take out an 8 and an x. That is the greatest common factor between those two. Now, here, if we're going to factor this fully, we know the greatest common factor between 16 and 24 is 8. So I can take out an 8. That's the most I can do. And if I want to accurately represent the binomial, 8 times 2x would get me 16x, and 8 times a positive 3 would get me 24. Here, the greatest common factor is 1. So technically, it's really 1 times 16x and 1 times 11y, because there are no common factors between 16 and 11. 11 being a prime number, so only 1 times 11. In this case, we'd say not possible. 3x minus 9, we should know that 3 is the greatest common factor between 3 and 9, so I will take out a 3. 3 times x would get me 3x, so 3 times x represents this. And then I need minus 9, so minus 3. And again, if you look at the distributive property, 3 times a negative 3 would get us negative 9. So I've accurately represented the binomial. Take a look here, follow along with me. The greatest common factor between these two numerical coefficients is 3. So I can automatically, I know I can remove 3 from both of these terms. Then I look at the exponents, the variables, and the letters are letters and their exponents. The x, I have x squared here and only x here. So at minimum, I should erase this, at minimum, I can take an x from both. Because at minimum, these two have in common at least one x. And in terms of the y, I have y cubed and y to the power 5. At minimum, we have y cubed in common. So what I put in brackets now, whatever I'm going to distribute, when I distribute 3xy cubed, when I distribute this to what's in the brackets, I should end up with 3x squared y cubed plus 6x y to the power 5. I must end up with that. So what am I going to multiply 3xy cubed by to get the first term, 3x squared y cubed? Well, 3 times a 1 will be 3, but I'm not going to write the 1 because that wouldn't be good form. X times what would get me the x squared? Well, x times x. and I already have y cubed. So there's nothing else I would have to multiply this by. Once I distribute 3xy cubed to the x, and I multiply, I will get 3x squared y cubed, which is exactly what I want. Now for the second part, for this portion here, I need to get 6x y to the power 5. If I multiply 3 times a positive 2, I'll get my 6. 3 times positive 2 will be 6. I already have an x here, so x times nothing will get me x. X times 1, an imaginary 1. And then I have y cubed, but I need it to be y to the power 5, so I need 2 more. So that's how I look at it, y squared. So to rewrite that answer down here, we have 3xy cubed times x plus 2y squared. And if you were to distribute this, 3xy cubed times that, you'd get 3x squared y cubed, and the 3x y cubed times that would get me plus 6x y to the power of 5. And that's it. And that's exactly what we were given originally, so that lines up perfectly. All right, this is a little bit different. Factor by grouping. Oops, let me get rid of that off the screen. Factor by grouping means you want to group pairs of numbers together, basically. If I have x plus 7 here and x plus 7 here, what I've got is a 3 is being multiplied by x plus 7, and I have a positive 5 being multiplied by x plus 7. So we can rewrite that in a simpler form by grouping. So in essence, I really have x plus 7 is being multiplied by a 3 and a positive 5. And if you remember from last day's work, if we were to expand this, we talked about taking one number, distributing it, and take the second term in the binomial and distributing it. So in essence, that accurately represents the same thing that you see here. We are in effect distributing a 3 to x plus 7 and a 5 to x plus 7. It's just a different way of writing it. Here, when you're given something like this, we have 4 terms. We want to look at the first 2. We're going to group those first 2 together and the second 2. What is the greatest common factor here? Well, both these terms have, I should write that the other way, both of these terms have an m in common, and both of these 2 terms have a 2 in common. So what I'm going to do for the first set, I'm going to take an m out. So I'll have m times x plus y. And for the second term, I'll use a different color for that, I'm going to take out a positive 2, and if I take a positive 2 out, I end up with x plus y. And if you look at that, 2 times an x is 2x, and 2 times a positive y is positive 2y. And same thing with the first set here. I have m times x, and that's mx, and m times a positive y would get me my. So this, what I've done on the right side here is in effect representing what's on the left of that equal sign. But now I can group. So if you remember what we just did in A, we had the 3 times x plus 7 and a 5 times x plus 7. So I can regroup that or rewrite that as 3 plus 5 being multiplied by x plus 7. We're going to do that here as well. So I have an m being multiplied by x plus y, and I have a 2 being multiplied by x plus y. So altogether, what's being multiplied by x plus y is an m and a positive 2. And that's factoring by grouping. All right, so you have to do some practice on your own. Here's your homework. Good luck.